Hola chicos, ¿cómo están? Bueno. Ok, todavía algunos entrando. Yo vivo en Buenos Aires, pero creo que mi castellano no está suficiente para una presentación así. Entonces, voy a hablar en inglés. If anybody wants to talk after, then podemos hablar en castellano, está bien. But I really don't think my vocabulary is going to be up to presenting correctly if I try it in castellano. So let's go ahead and get started because we're on a short time frame today. I'm Brad Irby. We're here for, I hope everybody's in the right room, event-driven architecture. What we're going to be doing is talking about taking legacy apps and moving them to microservices, Docker, Kubernetes, all that good stuff that you've heard about. And how do you do that? How do you get it from here to there without everything going down or shutting things down for a year for a rewrite? So that's what we're going to do. First, let's, por favor, recuerda calificarme. I'd love to hear what you have to say. So use this app. It's very cool. Have you guys used it yet? It's very cool. Yeah, give it a try. So this is me. I've got a book. We're short on time. Here we go. So what is event-driven architecture? There are various definitions out on the web. TechTarget has a good one here. But what they don't do, so we have to kind of take a step back for a second, because what these articles don't talk about is the difference between events and messages. A lot of times people confuse the two, think they're two terms for the same thing, and they're not. They're very distinct. So first, before we get into the main topic, let's spend about 3 minutes going over what the difference is so that when we get into the meat, when we get into the good stuff, then we'll know what we're talking about. So the difference between messages and events. Messages, first of all, they're a request for an action to be performed. So it hasn't been done yet. This is a request. They're short-lived. Once we process them, we throw them away. They've got a full data payload, so everything you need to process that message is in the message. Sometimes it'll be an ID. You have to go to a database and get additional information. But if anything coming from the user or from the input that's needed to be processed, you can process it right there. It's in the message. We only have current and future messages. Once you process them, they're gone. You can't look at history. And there's an expectation. This is the big one. There's an expectation that something will process the message. When you create a message, you assume there's something out there that's going to do something with it. And they're often sent in direct response to a user action. You know, a user does something on your UI, they press the save button, and you get a message that's coming in. So now let's compare that to events. So what an event does, event's kind of the opposite side. It's the other side of the coin from a message. An event reflects a completed action. Something has been done. A message is a request to do it. So they're medium or long-lived, meaning hours or even days. You can keep an event for days. We're going to talk about Target stores a little bit later. They keep their events for years. They've got about 6 years of every event that's ever happened. It's amazing. It's huge, massive Kafka installation. It's got a partial data payload. So in an event, it's what happened. It's state that's changed, and the only thing you store are the values that changed. You don't store the whole thing. Like if you're changing an order, you don't store the whole order. All you do is change the couple fields that were updated. Historical events can be consumed. This is going to come into play later. This is important. You can look at history. You can go look at events that happened 2 days ago, a week ago, a month ago. There's no expectation that an event has a listener. So you can publish an event and not know if there's anybody out there or not. That's going to come into play later again. And they're usually created in response to a data change. You change an entity in your database, you create an event to reflect that change. So messages and events, very different things. Real quick, a message-driven architecture drives from messages, obviously. But the message will initiate an event, and then the system will process that event, make changes to the database. Within your application, if you've got microservices or anything already, then they'll typically converse via messages because they're things that you can throw away. State changes are made, and then the message is discarded. And the thing is here, they're often synchronous. Most of the time, messages are synchronous. You process them and then send a result back. Events Same ideas, but the other side of the coin, like I was saying. This is microservices or other applications will subscribe to events, and they'll get notified. Similar to a message, you subscribe to a message, but you subscribe to an event, but the event has already happened. And this usually triggers further state changes, further events, something else subscribes, et cetera, and it kind of starts the dominoes falling. And the thing is, they're usually asynchronous. So events, they can sit out there for a while before they're processed. We're going to go over this in detail in just a minute. So let's see an example of both. Let me set up my example. We are building a retail store. We're selling t-shirts. So the process in our example that we're going to look at is somebody gets on, they order a t-shirt, they hit the big button saying buy. We create an order. There are various things that happen when you're creating an order. We charge the card because we want to get paid. We decrement inventory, and then we send an email to the user saying, oh, okay, everything's great. So that's the general process. It's not key to what we're talking about, but just so you understand where we're going. So this is the typical non-EDA architecture. So you've got your actor up here. He's buying his t-shirt right here, and he pushes his button, and it goes into the UI layer. And then that hands it to your application layer. You create your order. You talk to your domain layer. In this particular example, we've got an external inventory system. So it checks inventory, makes sure the shirts are there, charges the card, then goes back and decrements inventory, sends an email, everything, we're all happy. User's happy, everything's happy. So all of a sudden, your site goes viral. These are awesome t-shirts. Everybody's buying the things. What happens? Your site crashes. You get too much traffic, your site goes down. So let's look at why that might happen. What's wrong with this architecture? This is typical, by the way. If you have something like this, please don't be embarrassed. This is how things are usually built. I mean, when you're starting with something small, you build it like this because it's convenient. Everything's nice. Everything's in one spot. So this is a good way. Monoliths are not bad until they become bad. When you're building something small, it's you and your buddy, and you have 5 users out there, monolith is fine. When you've got 5 million users, okay, we got to talk. So what's wrong with this architecture? First of all, it's synchronous by default. So the entire time that they're going through this process here, the user's sitting there waiting. They can't wait to get their confirmation back that their t-shirt was purchased correctly. That's synchronous by default. So I'm not saying it cannot be async. I'm just saying by default. Your normal average dev banging out code, he's going to make it synchronous. To scale, you got to scale the whole thing. You got to scale up, not out. So you got to get a bigger machine or segment, but that's even harder to do. Unhandled exceptions. So what happens in something like this? If one of your systems blows up, say you're here, notify user, and you're all done. You've collected the money, you've sent the shirt, everything's good. Your email system blows up. This whole process could crash. That could bring down, blue screen, your server. And so now what does the user have to do? He's got to go resubmit his purchase because he doesn't know his purchase all went through. Now he's got 2 t-shirts on the way. So this could affect a lot of things. Failure in here can be unpredictable. And there's no record of how we got to where we are. So we look at the database. You come in the morning, you see that there are 10 t-shirts have been sold. You don't know how we got there. So let's do this. Let's just introduce a single event store, just one. All we're going to do, we're going to take an event store out here. I'm thinking Kafka, Kinesis, Azure Events Hub, something like that, an event store. So we're going to hang this off of here, and all we're going to do is create an order created event from here, boink, right in there. And we're going to create an order created event. And that's it. Everything else is the same. No changes at all. I mean, this is what, 1 sprint's worth of work? There's nothing here. Okay, so hands, what have we done? What have we done? What we have done is we've created the magic that's going to appear here in just a second. We've divided this application into 2. We've created an event store off to the side, right? And so all we're doing is writing our events to that event store, and that's it. Our main processing line is still there. Everything's still cranking just like it did before. But what we've done by creating that event store, now we can take some of those services that are in the middle and hang those off of the event store instead. So remember in the main line, we had create order, check inventory, charge the card, decrement inventory, because we need to check it before to see if we got any shirts to sell. So we check inventory, get our money, decrement inventory, send an email. We got all that stuff. So now, if we have a create order event that's in a separate event store, we can hang all that stuff off the event and be notified there. Okay? And the magic that that does for us is now the user doesn't have to sit through all of that stuff. What we do is the user comes in, he says, buy my shirt. We create the order, we report back to him, done, success. He's happy because he doesn't have to wait, 3 seconds to get his t-shirt. He's only waiting about a quarter second. So everybody's happy. We're happy because now we're async. Now we can handle this stuff at our own leisure. We can go get a cup of coffee, come back, handle these orders, and nobody's the wiser, nobody cares that it takes us 3 minutes to process these orders instead of 3 seconds. So that's the key, is we want to separate these things out. So once we have the event store there and all these processes off to the side, they can also, each one of those processes, since our event store is persisted, right? We've got these events out for hours, weeks, days, whatever you want. In fact, AWS Kinesis, the default is a week, unless you tell it otherwise. They keep events for a week. So what happens if our order processing system goes down? We reboot, it goes back, it reads events. Uh-oh, those events happened 5 minutes ago. No big deal. We grab them, we start processing. What would have happened if the whole system went down? We lost that order. So that's how you separate these things out. By creating an event store off to the side, you can separate these things out and process asynchronously. So we've got this one, our main thread over here that was, for you guys it was on the left, wasn't it? So main thread over here with the main processing UI and all that kind of stuff. And then we have all our new services. Oh, good, we're back. And then we have all our new services on the other side. Here we go. I'm on here. I'll get it. We've got all of our good stuff over here hanging off of our event store like I was talking about. We're still talking to our external inventory system. Not much has changed here. Yep. Okay. So not that much has changed physically. I mean, we've pulled all this stuff out of the big mess that we had over here. We've pulled it out, now it's over here. But that buys us so much. One like I was saying, one sprint's worth of work has all this potential. I'm not saying all of this is one sprint of work. That's a ton of work. But to get there, perfect. Thank you. To get there, to set it all up was one sprint's worth of work. Does this have a laser? I'll use this laser. I'll be ambidextrous. So what happens if we break up all of that stuff? So back here we had everything in one big microservice here, one Docker container. So now we start breaking those guys up. And now notice there are 3 of them here. We can scale these. We can scale these as much as possible. Now we're getting into scaling. Before, when everything was crammed into here, we had to scale up. We had to get a bigger server. Now we get to scale out. And also, kind of lost where I was, but we'll keep on going. Okay. Yeah, so we can scale these out, but we only have to scale the hot points. So if inventory system is really active, we scale just that. I mean, you guys know the promises of microservices, right? That's all I'm talking about here. What do microservices get us? Is this. Guy right there, that event store, is what opens it up. That opens that can of beans, and that's what we need to get from a legacy system to this. And since it is only one sprint, we can do it without taking the system down. That's the key. We can do it without taking our system down. We don't have to shut it down. We don't have to go to our bosses and say, I'll be back in 6 months with this awesome thing. He's never going to buy that, right? You got to keep building features. You got to keep doing all this stuff. You got to pay the bills. So that guy is what is the key to making all this happen. Okay, sounds amazing, doesn't it? Let's all go do it. Now, there are some downsides. Okay, so one thing, the biggest downside that I've found in selling this to the business, the devs, the techies, they don't care. Eventual consistency, that's fine. The business doesn't like it. Eventual consistency. So what happens is the user pushes their order a t-shirt button, and they get a notification back immediately saying, order good, you're on your way. And then we get into the order, we find out their credit card's bad. What do we do? Now we got to send them an email saying, oops, sorry, we can't do that. You got to give me a new credit card, you got to do something else, you got to fix this. So eventual consistency. The user gets an approval, and then later he has to be notified that it's not there. That eventual consistency also happens within the app, within our data. So when you try and sell this to management, you're going to go say, this is a great thing, Brad is so smart, he told me this, we're going to do it. But there's this eventual consistency thing. They are going to think back to business intelligence and cubes and things like that would take a day to roll a new cube, do the analysis, and they get all updated tomorrow. No, that's not what this eventual consistency is. This is less than a second, typically. If you're having a bad day, it'll be 3 or 4 seconds. So when you're pitching this, when you're saying eventual consistency, make sure to say this is less than a second eventual consistency. But there is a point in time where things aren't quite up to date. Let's see. So the immediate feedback, that's what I was talking about. The user gets an email later saying the order didn't go. And it is a new paradigm. It's a different way of thinking about things. So I assume everybody in here is technical, right? Probably a couple managers, but mostly technical. It's different. Because there are different ways of thinking about async programming with an event store, because you don't have control of everything anymore. You have to respond to something whether you like it or not. If you're building in Docker, Docker's for those that made the conversion to Docker. Okay, let's take a poll real quick. For those who used to build no Docker, now they're building Docker, was it a different way of going about things? No, really? Oh, I found it so different. You can build like you own the entire machine when you're building Docker. When you're building microservices, you don't have to worry about competing, other threads competing for resources, because Kubernetes will scale up your Docker for you. You know, you can do a lot of things as if you're back home on your desktop PC with Docker. I really like it. But it is a new paradigm. Eventing is a new paradigm for devs. They're going to have to learn it. So let's talk about the advantages. So when you're putting your PowerPoint together to go pitch this to management, what are you going to say? There are advantages to users, to prod, to devs, and the business in general. There are a lot of advantages here. First, let's talk about the users. So there's faster response time. Let me check my time, make sure. How are we doing on time? Yeah? Faster user response times. All this here is no longer here. So the user gets a response right away. So they don't have to wait for all that other stuff to happen. They get a response every now and then. They'll get an email saying, oops, sorry. But in general, they get a response right away saying yes or no, and they can go about their day. That makes users very happy when they get a fast response. Let's see. So if something fails, no resubmission. So in the old system, when everything was in the main line of code, if something failed, like that email at the end, it brought down the whole thing, you lost your whole order. Now they got to resubmit. Now you don't. If something fails over here, inventory system fails, the order processing, charging the card, something like that fails, we go fix it in the background, user never knows. So we can fix that, and the user never knows. That's key. Them knowing is a bad thing. And also, okay, so there are a couple points in this talk that the people who are on their phones, they need to put them down. This is one. You can go back and reprocess other things that have already happened. So if you've got a bug in your inventory system, you can fix the bug and then go back and reprocess things from 3 days ago. You can fix your stuff. You can fix a bug retroactively because all your events are still there. So this is cool. This is really cool that you can do this. Or consider you're adding a new feature to one of these processes. You can go back and reprocess everything. Bring that feature up to date. If you're saving 6 months worth of history, you can go back and reprocess 6 months. So let's see. And request isolation. It's more confidence in the system. So remember we were saying that if one of the external services, one of these guys over here, if one of these fails, we can go fix it and nobody knows. The user doesn't know either. So if every one of those systems had a bug in it that would cause things to crash, crashing bugs have just decreased by 60%, 70%. So the user is ecstatic. They're loving that. And behind the scenes, we're fixing things, we're getting it better, but the user never sees it. So lots of advantages for the users. For prod, then you can scale what and when necessary. You scale the hot points. You scale, there's an implicit support of horizontal scaling. Microservices, again, you can scale, oh, thank you. Wow, I've been talking really fast. So you can scale horizontally. You can just throw servers at this thing. You can throw a serverless at the thing without having to worry about overloading your main application. And with Kubernetes, Docker, you can also respond to temporary pressures. So if you've got a burst, imagine you were working for Apple and you release the iPhone now. What do you think is going to happen to your servers? I mean, it's going to go through the roof, right? You're going to go from 0 to 10 million transactions a second. You got to be able to scale that out. You got to be able to scale out the bursts. This allows you to scale out the bursts with Kubernetes, Docker, and all that. You can scale the bursts. And this guy right here enables you to scale those bursts. So service failures, they don't affect anything else. When everything's all in the same address space, one thing goes down, they all go down. One crashes, everything else comes down with it. Now everything is separate. So, and especially with Docker, if just one of these guys, you got 3 of them here. If one of those goes down, who cares? Kubernetes throws it away, brings up another one, and you're back to where you were. And you guys personally never even knew. But say the whole thing goes down, you've got a bug in the code, and the whole thing goes down, it's not going to affect anything else. Your event store is still there, safely keeping all of your events. The other processes are still cranking away. You've just kind of got a backlog. And then when you bring these things back up, they chew up the backlog again. Let's see. There we go. Same thing if all of them fail, right? We can have the whole back end. I mean, AWS can go down. As long as our front end doesn't go down, everything's okay. So everything can fail. We can still bring everything up, and we can still survive. Better fault tolerance. Yeah, so that we don't have to resubmit. The user doesn't have to resubmit the request. Everything can be handled from within the event store. So actually, there's a point that I meant to. So systems can come down minutes or hours or days later. So it can be days that you're down. I mean, think of your current maintenance windows. You're probably pressured to get maintenance done in, 20 minutes, half an hour, something like that. You want to get it down and up, so you're inside your SLAs. This way, your SLAs are much more important. You can still satisfy the SLA, but still be down for hours, getting something up and running, maybe releasing a new version, get it back up. Everybody's, you're nice and safe. You're happy with how it's done because you've tested it nice and thoroughly, and you're back up. You're still within SLA. Customers don't know. So advantages for devs, advantages for you guys. This is async by default. Before I was saying your normal average dev, when he's building something on a website, he's building an ASP.NET core app, and he's doing Razor pages or Razor forms or something like that, and he's building his controllers. He's going to build all those synchronous. It's just the easiest way. When you sit down to bang out some code, you build a synchronous. You can add async stuff in there. You have to go out of your way to do it. The async, is the default way of doing things. So once you create that event, everything else is async. You don't really have a choice. If you can, or if you need to, you can make this synchronous. If there's a pressing need, say you are bound and determined, you do not want to tell the user you have a t-shirt when you don't. And so you want to hit that inventory system and check before you get back to them. You can still add the link from here to the inventory system, and everything can be synchronous. So you can add synchronous code if you need to. You can have messages that balance processing between services, things like that. So you can add synchronous if you need to, but you have to go out of your way to do so. And that's the way it should be. That's the appropriate way. Let's see. Yeah, it enables complex operations. So the front end can submit just an order created message, and then all that complexity, all the handling, everything that needs to be done is in the back end. They're all in back end services. You don't have it all jumbled up in the UI. So that's where you want it. You want all the complexity in the back. You can replay event creation. Yeah, so this is one of the cool things. You can replay, so imagine you are Target and you survive the Christmas rush. You got a bazillion requests coming in per second through the Christmas rush, and you're able to get through it. Everything's done. Whew, we're done. Next Christmas, you're expecting even more. How do you know you can handle it? You go back, you reprocess your events. You pull your events from previous Christmas and cram them through your new systems. See how they work. Because everything's there. Everything that ever happened is right there. So you can test new systems as they come through and make sure it can stand up to the workload that you're gonna see. You can run them through at twice the speed. You can run them 4 times the speed. You can just dial up the speed until your systems fall over, and then go to management and say, yeah, we can handle 10x what we did last year. They're gonna love that, and you can prove it. You got numbers. So replaying events is huge. It's huge. And you can recreate the bugs with actual production data. So how many times have you had QA or customer service or somebody like that come to you and say, if you kind of hold your head like this when you push the submit button, then it blows up on me. Well, okay, let's go, but tell me exactly when that happened, and I'll go check the data. And you go back and you rerun those events. And you find out, yeah, when they hold their head like this, they're actually clicking on the wrong button. So you figure out what's going on. So yeah, you can recreate bugs from production data. Here we go. So, okay, here's the other part where if you're on your phone, put your phone down for a second. You can test with production data. Who wants to do that? I see a couple hands. Yeah, let's test with production. No, this is cool because the events are read-only. Once you write them once, they're done. You can never, ever change them. It's like an accounting system. When you debit one thing, if you realize later, oops, I messed up, you got to credit it back. You can't go back and change that. You got to put a reversing entry. Events are the same way. Once you write it, they're done. So what's wrong with testing your brand new systems on production data? You point them to the production event stream and see what happens. They start processing that thing. As long as you don't write your events back, obviously. You don't want to write them to events, to the production. But you can read from production and test and make sure. I mean, imagine that for your QA is you just take your system, you turn it on to production data and let it run for a couple days. See what happens. QA is going to love that. So this is awesome. Testing with production data and being able to replay events from history are fantastic. They're brand new tools in our toolbox. Let's see. So, okay, let's talk about the business because they're the ones that are going to have to write a check for all this, right? So there's one source of truth. If you look at the current systems out there, you've got in any reasonably large company, you're going to have a lot of different systems, each with its own database, each with its own view of truth. Each one is going to think that it knows what's going on, and they may disagree, and now their battles, their arguments, whose database is right. No more. Now you have a single source of truth. If it's not in that event store, it never happened. Okay? So if you look at your system and it doesn't agree with the event store, your system is wrong. You got to go back and reprocess those events and bring your database back up to speed again. The business loves this because the CEO, the whole C-level, they're tired of the arguments of saying my system's right, no, my system's right. They're looking at ports from two different things, giving them different numbers. So this is huge. One source of truth. You have enhanced planning data. So you can go back, say you're like Target, you're keeping this for years. You can go back and you can graph usage, you can graph order creation, you can graph things that you didn't even know you wanted to graph. You can go back in time. You have a great idea today. I would love to see what happened with this thing. How many people are ordering purple T-shirts? You go back and you graph when they did it, what time of day, what day of the week, where they were in the world, all these things. You can graph all this stuff and get data after the fact. Let's see. So domain decoupling is faster response to changing market. So you can get your features out there faster. This is one of the promises of microservices. This is why we're trying to go this way, right? Because microservices are easier to enhance. They're easier to add features. They take smaller teams, faster teams. You can keep microservices all in your head at the same time. So when product comes to you and says, we want this cool new feature, you can think it through and say, okay, that's probably 2 sprints. Or they say, well, we want this other feature too. Whoa, that's like 10 sprints. You know this because everything's small. So the domain decoupling. So who's doing domain-driven design? Anybody? Couple? Not many? So the word domain just comes from domain-driven design, so it's a different ideas. Like payments in retail, payments would be a domain, inventories a domain, orders are domain, items that can be ordered, which is different from inventory, those kind of things. All separate ideas. So decoupling those means you can build features faster. Better error recovery. Should anything go wrong with the backend system, we can reprocess. That's what we were talking about earlier. We can reprocess these things, retroactively reconstruct the data. Say you lost an entire database. Say your database crashed and you had no backups, or at least the backups were corrupt, which I've been through that before. That's not fun. You can go back and recreate everything, assuming you have all the events, right? So if you're saving them forever, you can recreate from the beginning. So, and this is another big advantage, special customer features. So what you can do is on your event store, you can build, say you've got one big massive customer, you love this guy, he pays 90% of your salary. So you want to keep this guy happy, and he wants a special feature that makes no sense. So you say, sure, I'll do that. What do? You build it in its own separate little microservice off to the side that's reading from your event store, and you calculate whatever numbers he thinks are valuable, and you give him those. So you can do customer-specific features and get those out fast, get them out the door without affecting the main line of, you don't have to check these into master if you don't want. You can have a separate Git repo that contains all of that code. And those features, this strange feature that your biggest customer wants and you don't know why, you can go back in time, recreate all that data back in time. There we go. So let's talk about just some experiences. Let me go back, see if I can get this on GILT. There we go. So let's just talk about some experiences that we've seen in this migration process. What's the result here? This is all great talk. Show me the numbers. Show me the money. What movie is that from? Show me the money. So this is GILT. They were a startup that moved from a monolith to microservices using event-driven architectures. This was about 3.5 years ago, something like that. They gave a presentation recently on their results as they went through it, and you can see. So they've got a decent-sized team, 150 people. They went from 150. Can you imagine a monolith with 150 people on it? That's a nightmare. How do you do that? But they had 150 people on this monolith, and they chopped it all up into little microservices, and they had small focused teams on each microservices. 300. So from a monolith with 150 people on it, they broke it up into 300 microservices, 1,000 plus Git repos. And they're having about 100 or so production releases per day. So they push these out that fast. They're supporting 10,000 requests per second, and you can see, so the red, so it's kind of hard to read. The red is number of services, the blue is headcount. So you can see right at that crossover point, they've hit that magic place where you don't need as many people as you did before to handle as much code. So they're cranking out these microservices, and they're much easier to manage. So you can see, I mean, put your manager hat on for a second. You can imagine what the benefits are in payroll, or maybe not payroll, additional projects. You know, they can do so many more things with the staff that they're given. So these are all excellent arguments for this, for event-driven architectures in general. Now let's look at Target for a second. There we go. Whoop, come back. Where's Target? Come here, Target. So they had, so Target divides their whole company. You guys know Target, right? Walmart, kind of very similar. Carrefour, same idea. So they had probably about 15 different main business divisions within Target that did dramatically different things, like little companies all within Target. And each one had its own complete set of internal services, internal applications and everything like that. Talk about one source of truth. Now we got 15 sources of truth, and everybody is adamant that theirs is right. So the CEO was getting upset. He didn't know what was right, what was wrong. So he was saying, he went to the CTO and said, fix this, as CEOs tend to do. So they decided to go all APIs. They went a single logical Kafka installation. We'll talk about what Kafka is in just a second. But Kafka is basically an event store. So they did one massive logical Kafka installation. Lots of different topics and everything, but basically you can think of it as one big massive Kafka, and hung everything off of that. They demanded that all business processes hung off of this Kafka. And so they started pumping events into that, and that's how everything started to talk. And so now all of their development is APIs. They've got front ends, but those are completely separate. All the business data, everything is managed completely 100% in APIs now. Average time from code commit to prod decreased by 20%. They were pumping the code out to prod much, much faster than they were before. So they've got 41 general data topics. That's not many, but they put a lot of time. The EDA, when you get into event-driven architectures, thinking out the events is one of the hardest things that you're going to do. Plan to put enough time in upfront planning, because if you don't do that right, you're going to start building code against it, and then you're going to realize once you're halfway done that your events aren't quite right. You're going to have to redo a lot of stuff. So look into something called event storming. It's a way of getting all the people in the room, everybody shouts out their ideas, and you get all the events on the board. And it's a great way to plan. So so back to Target. I'm getting distracted here. So they support about 70 million visitors a month. So they've got some decent throughput. Okay, so how do we do EDA? Let's talk about some technology for a second. There are a couple ways to do it. You can have hosted or DIY, do it yourself. Hosted, you've got your choice. If you're an Amazon shop, you go Kinesis. If you're an Azure shop, you go Event Hub. They both have minor pros and cons compared to each other, but basically they do the same job and they both do it well. They're easily turned on and used. 5 minutes, you say, give me one. 5 minutes later, you've got it and you can start putting events in it. So both of them are excellent solutions, and they're fairly inexpensive. You typically pay per event, like millions of events. They measure it by millions. So if you're putting together something small, you want a little test app or something that's just used within the company, 10, 15 users, something like that, you can probably slip in on their free tier to give it a try, see how it works. But these are turnkey solutions. They're very easy. They're just not as rich as Kafka. So Kafka is kind of the big gorilla in the space. It's an excellent, excellent tool. Very versatile, very fast, very powerful, hard to manage. So you've got to have a solid DevOps team that can manage this. You have to have your own self-managed Kubernetes. It only runs on Docker and Kubernetes, so you got to get your own Kubernetes set up. It needs 7 zookeepers plus your Dockers. There's a lot to it, but like I said, there's a lot of power. So if you're a build your own kind of team, Kafka's a great way to go. If you're a turn the key and just let's get this done kind of guy, or girl, sorry, then Amazon and Azure are good ways to go. Kafka has a query language that's very, very cool. So if you're thinking Kafka, this is an argument for Kafka. They've got a floating window query language. So you create a query similar to just raw regular SQL, but the window moves. And so your result set, you issue the query once, and then your result set is constantly changing. Your result set is a stream from this query. It's really cool stuff. So you can manipulate your data that way, change raw event streams into something that's more intelligible, something that's more manageable for yourself, and then follow that stream. It's very cool stuff. Kafka is really great. There is another option that I've not, back up, there we go. There is another option. I've not used that, so I can't really say do it, but the marketing sounds good. It sounds like they're on the right track. DynamoDB, they've got something where you can just flip a switch, and every time you update a row in Dynamo, it will detect the fields that have changed and stick them in an event stream for you. So no code at all. You just click a little box, and all of a sudden you've got an event stream. So like I said, the marketing looks good. I've not tried it. If anybody tries it, let me know. I'd like to hear how it goes. So I think we're running out of time, and if I can get to that next slide, there we go. I think we are out of time. So that's all I have on event-driven architectures. I hope I didn't talk too fast through the technical issues we had there. If you need to connect with me, here's a lot of ways that you can do so. By the way, these slides are on SlideShare. You can get it on the Brad Irby link here. Brad Irby, click NetConf UI 18 is the SlideShare. Connect with me LinkedIn, Twitter, email, whatever. Send me questions. Let's start a conversation. That's all. Thanks for coming, guys.